Hey guys, welcome to another episode of the Human AI podcast. Today we're going to talk about bowel cancer, pathology, screening processes, and I'm here with AI, specifically Grok. Grok is going to explain to us this topic. If you're unfamiliar with the structure of the podcast, I'm just a student, I ask questions, I don't know much about the topic, but Grok does. So, without further ado, let's kick things off. As always, remember, take everything that AI says with a pinch of salt, as it might be inaccurate. Cross-reference everything you hear. Grok, introduce us to today's topic.
All right, thanks for the intro. Today, we're diving into bowel cancer, or colorectal cancer, which is a malignancy of the colon or rectum, and we'll cover its pathology, how it develops, and what it looks like in the body, plus the screening process to catch it early. It's a major health issue, but understanding its mechanisms and how we detect it can really help with prevention and treatment. So let's get started with what you want to explore first.
Well, what are the key, tell me about the key facts about bowel cancer. Let's start from there.
Bowel cancer, or colorectal cancer, mainly develops from genetic mutations, lifestyle factors like high red meat or low fiber diets, and chronic inflammation, with age over 50 being a key risk factor. These trigger abnormal cell growth in the colon or rectum, often starting as benign polyps that can turn malignant over time.
And does ulcerative colitis and chronic Crohn's disease, are they risk factors for bowel cancer?
Yes, both ulcerative colitis and Crohn's disease are risk factors for bowel cancer due to chronic inflammation in the gut, which can lead to abnormal cell growth over time. The risk increases with longer disease duration, especially after 8-10 years, and is higher in ulcerative colitis patients with extensive colon involvement.
And how does high fiber diet reduce bowel cancer risk?
A high fiber diet reduces bowel cancer risk by speeding up stool transit through the colon, diluting potential carcinogens, and promoting a healthy gut microbiome that produces anti-inflammatory compounds like butyrate. Fiber also binds to harmful substances, reducing their contact with the colon's lining, which lowers the chance of DNA damage and abnormal cell growth.
So a polyp is a protruding growth into a hollow viscous. What's the difference between a polyp and a tumor and an adenoma?
A polyp is a growth protruding into a hollow organ, like the colon, often benign but sometimes precancerous, while a tumor is a broader term for any abnormal tissue mass, which can be benign or malignant, like cancer. An adenoma is a specific type of polyp made of glandular tissue, usually benign, but with potential to become cancerous, ADSN or carcinoma, if mutations accumulate.
And what is dysplasia? And what makes a cell cancerous?
Dysplasia is when cells in a tissue, like a polyp or adenoma, show abnormal growth and structure. Think disorganized, oddly shaped cells with larger nuclei, but aren't yet cancerous. In the colon, it's a warning sign of potential cancer risk, often seen in adenomas. A cell becomes cancerous when genetic mutations disrupt normal controls, causing uncontrolled division, invasion of nearby tissues, and sometimes spreading, metastasis, driven by DNA errors in genes like APC, KRAS, or TP53 in colorectal cancer.
Okay. What's the pathological features of polyps then?
Polyps in the colon, like adenomas, show pathological features such as abnormal glandular structures with dysplastic cells, irregular, crowded cells with enlarged, dark nuclei, visible under a microscope, ranging from low-grade, mild changes to high grade, severe, near cancerous dysplasia. They can be pedunculated, stalked, or sessile, flat, with adenomas often having a tubular, villus, or tubulovillus architecture, and their size, number, and dysplasia grade predict the risk of progressing to colorectal cancer.
And why do we have many goblet cells in hyperplastic polyps?
Hyperplastic polyps have many goblet cells, mucus-producing cells, because they arise from overgrowth of the colon's normal mucosal cells, particularly goblet cells, which are naturally abundant in the intestinal lining to lubricate and protect it. This benign proliferation, often driven by mild genetic or environmental triggers like inflammation, leads to an exaggerated but non-dysplastic increase in goblet cells, giving the polyp its characteristic serrated, mucus-rich appearance under a microscope.
Okay, let's talk a bit about tubular adenomas now. Hyperplastic polyps, villus adenomas, and tubulovillus adenomas. And explain to me the differences.
All right, let's break down tubular adenomas, hyperplastic polyps, villus adenomas, and tubulovillus adenomas in the colon, keeping it clear and concise. Tubular adenomas are the most common type of adenomatous polyp, made up of tightly packed, tube-like glandular structures lined with dysplastic cells, which can range from low to high grade, and they carry a moderate risk of turning cancerous, especially if larger than 1 centimeter. Hyperplastic polyps, unlike adenomas, are benign overgrowths of normal mucosal cells, rich in goblet cells, with a serrated, sawtooth appearance, and generally have little to no cancer risk, unless they're large or in specific subtypes like serrated adenomas. Villus adenomas have finger-like, villus projections of glandular tissue, often larger and with more severe dysplasia than tubular adenomas, making them higher risk for progressing to colorectal cancer, sometimes up to 40% if untreated. Tubulovillus adenomas are a mix with both tubular and villus features, and their cancer risk falls between tubular, lower, and villus, higher, depending on the proportion of villus tissue and
What is the
degree of...
difference between tubular and villus then? And polyp versus adenoma?
Tubular adenomas have tightly packed tube-like glandular structures with dysplastic cells, giving a lower cancer risk, while villus adenomas feature finger-like villus projections with more severe dysplasia, raising their cancer risk significantly. A polyp is any growth protruding into the colon, which can be benign, like hyperplastic or precancerous, whereas an adenoma is a specific polyp type with glandular tissue and dysplasia, carrying a higher risk of becoming cancerous.
Okay, can you quiz me a bit between these terms?
Sure, let's do a quick quiz to test your grip on these terms. I'll ask one question at a time, you answer in a few words, and we'll keep it moving. First up, what type of adenoma has finger-like projections and a higher cancer risk?
Villus adenoma.
Spot on. Villus adenoma is correct. Next question. What's the term for any growth protruding into the colon, whether benign or precancerous?
Hyperplastic polyp.
Casi, pero no del todo. Dijiste
Never
hiper...
ever dare to speak another language.
Vale, parece que quieres que hable en español.
Please speak in English, dude. Please.
My bad, dude. Back to English. The answer to that last quiz question was just polyp, for any growth protruding into the colon. Ready for the next one? What adenoma type has tube-like structures and moderate cancer risk?
Tubular adenoma.
Nailed it. Tubular adenoma is right. Next question. Which polyp type is usually benign, serrated, and full of goblet cells?
Is this tubulovillus adenoma?
Nope. Tubulovillus adenoma has a mix of tubular and villus features with some cancer risk. Not quite the benign, serrated, goblet cell-rich one we're looking for. The correct answer is hyperplastic polyp. Want another question or to revisit something about these polyps?
No. Let's talk about the adenoma carcinoma sequence. So this is a stepwise progression from normal mucosa to adenoma to cancer. Talk to us about the morphological features like histological ones, macroscopic features, and yeah.
The adenoma carcinoma sequence describes how normal colon mucosa transforms into an adenoma, then potentially into colorectal cancer, through a stepwise progression driven by genetic mutations, with distinct histological and macroscopic features at each stage. Histologically, normal mucosa has orderly crypts with uniform goblet cells, but in adenomas, you see dysplastic cells with crowded irregular nuclei, ranging from low-grade, mild atypia, to high-grade, severe, near cancerous, in tubular, villus, or tubulovillus patterns. Carcinoma shows invasion through the muscularis mucosa with atypical, disorganized cells, glandular distortion, and possible necrosis. Macroscopically, normal mucosa looks smooth and flat. Adenomas appear as polyps, pedunculated, stalked, or sessile, flat, ranging from a few millimeters to centimeters, while carcinomas present as ulcerated, bleeding masses or annular strictures, often larger and irregular, disrupting the colon's normal contour. This progression, often linked to mutations like APC, early adenoma, KRAS adenoma growth, and TP53 carcinoma, reflects increasing architectural chaos and invasiveness, visible both under the microscope and to the naked eye during colonoscopy. Want to zoom in on specific mutations or how these features guide diagnosis?
What is familial adenomatous polyposis?
La polyposis adenomatosa
Okay, if you ever hear me speak a language that you think is not English, please ignore it and answer in English. It's a mistake from your behalf.
Got it. I'll stick to English no matter what, even if I hear something that sounds like another language. So, you mentioned familial adenomatous polyposis. Want to dive into that, or keep
Yes.
going with the All right. Since you mentioned familial adenomatous polyposis, FAP, I'll assume that's the focus. Familial adenomatous polyposis is an inherited condition caused by mutations in the APC gene, leading to hundreds to thousands of adenomatous polyps in the colon and rectum, with a near 100% risk of colorectal cancer by age 40, if untreated. These polyps look like typical tubular or tubulovillus adenomas macroscopically, but histologically show dysplasia, and the sheer number, often carpeting the colon, distinguishes FAP from sporadic adenomas in the adenoma carcinoma sequence, requiring early screening and often prophylactic colectomy. Want to explore FAP's genetic mechanisms?
Yeah,
It's
so
linked.
tell me about the chromosome 5q21, the APC gene. Tell me about the genetics.
Familial adenomatous polyposis, FAP, is driven by mutations in the APC gene on chromosome 5q21, a critical tumor suppressor gene in the adenoma carcinoma sequence. Normally, APC regulates cell growth by controlling the Wnt signaling pathway, preventing excessive cell division in the colon's mucosa. Mutations, often inherited in FAP, disable this control, leading to uncontrolled cell proliferation and the formation of hundreds to thousands of adenomatous polyps by adolescence or early adulthood. These mutations are typically truncating, meaning they produce a shortened, non-functional APC protein, and are autosomal dominant, so a single mutated copy from one parent is enough to cause FAP, with a 50%
So
chance of passing it.
FAP is a bunch of polyps.
Yeah, FAP is wild with all those polyps carpeting the colon. Want to dig deeper into how those APC mutations kickstart the adenoma carcinoma sequence? Or maybe jump to how we screen for FAP to catch it
I want
early?
to ask about the two-hit hypothesis in hereditary and sporadic bowel cancer.
The two-hit hypothesis explains how colorectal cancer develops in hereditary cases like familial adenomatous polyposis, FAP, versus sporadic cases. In FAP, individuals inherit one mutated APC gene, first hit, and a second somatic mutation or loss of the normal APC gene, second hit, in colon cells, triggers polyp formation, leading to cancer. In sporadic colorectal cancer, both APC gene hits are somatic mutations acquired over time, often due to environmental or lifestyle factors, making it slower and less predictable, but following the same adenoma carcinoma sequence.
Tell me the difference between the two hypotheses then.
The two-hit hypothesis applies to both hereditary and sporadic colorectal cancer, but differs in how the hits occur. In hereditary cases like FAP, the first hit is an inherited APC gene mutation present in all cells, and the second hit is a somatic mutation or loss of the normal APC gene in a colon cell, rapidly leading to polyps and cancer. In sporadic cases, both hits are somatic mutations acquired over time in a single colon cell, typically taking years to accumulate due to environmental or lifestyle factors, resulting in a slower progression to cancer.
I don't understand the difference between these two. So in a few words, very simply, what's the two-hit and what's the other one?
The two-hit hypothesis says colorectal cancer needs two mutations in the APC gene. In hereditary cases like FAP, you inherit one mutation and get a second one in a colon cell, causing rapid polyp growth. In sporadic cases, both mutations happen randomly in one cell over time, taking longer to form cancer. There isn't a separate other hypothesis here. It's the same two-hit idea applied differently based on whether the first mutation is inherited or not.
I don't get it.
All right, let's make the two-hit hypothesis crystal clear and super simple. For colorectal cancer, the APC gene acts like a brake on cell growth, and you need both copies of it broken. Two hits to start forming polyps that can...
I see. And the second hit leads to loss of heterozygosity. Okay. And what's so bad if we have a faulty APC gene that it will lead to cancer?
Yeah, you got it. The second hit in the two-hit hypothesis often causes loss of heterozygosity, where the remaining normal APC gene is lost or mutated, leaving no functional copy to control cell growth. A faulty APC gene is bad because it normally acts like a brake on the Wnt signaling pathway. Without it, cells in the colon divide uncontrollably, piling up mutations like KRAS or TP53, forming adenomas that can progress to colorectal cancer.
So what's the difference between normal FAP and attenuated FAP?
Normal familial adenomatous polyposis, FAP, causes hundreds to thousands of colon polyps by adolescents due to severe APC gene mutations, with a near 100% colorectal cancer risk by age 40 if untreated. Attenuated adenomatous FAP, AAP, caused by milder APC mutations, leads to fewer polyps, 10 to 100, later onset, and a lower but still significant cancer risk, often sparing the rectum and requiring less aggressive management.
Okay, can we talk a bit about Lynch syndrome, HNPCC?
Lynch syndrome, also called hereditary non-polyposis colorectal cancer, HNPCC is an inherited condition caused by mutations in mismatch repair genes like MLH1, MSH2, MSH6, or PMS3, leading to a high risk of colorectal cancer and other cancers like endometrium or ovarian. Unlike FAP, it doesn't cause tons of polyps, but cancers develop faster from adenomas due to defective DNA repair, with a lifetime colorectal cancer risk of 50–80%.
Okay, and what are the genetics of Lynch syndrome then? So we have guanine thymine instead of guanine cytosine, and adenine cytosine instead of adenine thymine.
Lynch syndrome is caused by inherited mutations in mismatch repair genes, MLH1, MSH2, MSH6, PMS3, or rarely, EPCAM, which normally fix DNA errors during cell division. These mutations are typically single nucleotide changes, like swapping guanine cytosine for adenine thymine, or small insertions deletions, leading to defective repair and microsatellite instability. This causes DNA errors to pile up, especially in genes like TGFBR2, speeding up adenoma to cancer progression with no specific single base pair change, e.g., thymine for guanine cytosine, universally defining it, but rather varied mutations across these genes.